This one's going to be a long shot, but I might as well give it a go, being that everywhere I look, everybody tries to explain core formation with gravity alone, and I think that's dumb, because there are heavier elements than iron and nickel. Why aren't those in the center of the Earth in large quantities, as are ferromagnetic materials such as iron, nickel, and cobalt? And a few ideas I want to throw out there for people. Electroplating, okay? This is a widely used process in industry. It's how people plate things with chromium or silver plating or gold plating. It's a very valuable process. What you have is you have a gold anode and you have a solution that has gold ions in it, and you induce a current through the solution, negatively charging the cathode, in which the positive, positive ions can travel through the liquid and deposit themselves onto the cathode. So the cathode is where the deposition takes place. Think of a pearl, okay? You have your cathode that's going to be electrically charged, and then the anode, the material from the anode moves to the cathode, plating it. And over time, that object gets bigger and bigger and bigger. Granted, if you electroplate stuff, you don't really want to plate it very thickly. I mean, sure you can depending on what needs to happen, but you can plate it thin, or you can leave it in there for the entire duration, maybe a few days or weeks, and you can very, very, very thickly plate whatever it is that you're leaving in there. Now imagine if you take the timeline of a star, which is many billions of years, and you electroplate a core. Now, I do believe if something is many billions of years old, given if it has been electroplated with iron and nickel, you can make the core incredibly massive. So, as per a previous video, we can determine the age of an iron core, how long it took, if we find out the equations for if the core of the Earth was electroplated via a star. We can find out how old the Earth really is, and probably is in excess of 70 billion years old, because the crust is very young, like 3.5 billion. Core is the first thing to form. That's the oldest structure on the Earth. It's not the crust. Think of, I don't know. Well, I'm not going to talk about that. But anyways, here you have the electrically conducting solution. You have your anode and your cathode. Now, the process that I think core formation happens, or the stage in star evolution where core formation happens, is during red dwarf stages. That's why I believe it happens. Might happen during brown dwarf stages, not too sure. But I think core formation starts during red dwarf stages, because the red dwarfs, they flare a lot more violently than a younger star. Think about it like this. If a younger star is mostly hollow and it starts collapsing on itself, that means something's connecting in the middle, which would induce huge convective currents inside the star, okay? And those convective currents will fuel very, 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 very large flare events in which the material is expelled outwards. Now, I'm not too sure about this. This is a very new idea for me, because I'm trying to connect electroplating with star evolution. I don't think that's ever been done before. So here we go. The cathode, the material that gets deposited, is the iron, nickel, and cobalt. That's in the center. The electrically conducting solution is the fact that the iron inside the star is already ionized. That's the plasma. Okay? It's very similar to vacuum vapor deposition. I'm not too sure what the real difference is, besides the fact that obviously vacuum vapor deposition would work in a vacuum, and electroplating would have a conducting solution, which would be a liquid phase. So I'm not too sure if this process happens inside vacuum, or if it needs the solution to be there already as plasma, but more on that later. Now, here are some steps that I'm throwing out there. You have your electrically conducting matter, your plasma and ions, which is in the form of iron and cobalt and nickel ions. That moves through a magnetic field. So granted, you already have a small magnetic field. Think of this as a small core of the Earth right there, okay? It already has a magnetic field. And if you have the ions traveling through the magnetic field, what it's going to do, that's the second step, what it's going to do is it induce electrical current, meaning that's your battery for the electroplating process. And then once you have your battery, that is, in essence, will force there to be an anode and it will force there to be a cathode. So naturally, which one will it choose for it to be the cathode? I think it's the object that's forming in the center, which is the iron. And that in turn induces a larger magnetic field because the cathode begins to have stuff layered onto it and it grows bigger and bigger and bigger. And as that magnetic field grows larger and larger, it also facilitates iron clumping together. Now, this is something that really, kind of shocked me, is that iron is ferromagnetic, meaning if there's a magnetic field around, a strong magnetic field, iron will go to it because iron is magnetic. If you take a magnet and throw it against the refrigerator, it's going to stick right to it. Same thing with nickel, I believe, or maybe not nickel, I can't remember. I think cobalt was ferromagnetic. So also we have to figure out a way to get nickel in there too. And that's where I was trying to go with explaining what would be charged and how much charge it would have. For instance, if you have iron, it could be a -1, -2, or if you have nickel, I think it's Ni. You could have 1, maybe 2 of them, or maybe even 3. Plus you can go the opposite direction. The iron can be extremely positive from the ions or from the electrons being ripped away. But that's a whole hell of a lot of research to do, and I just thought I'd share this with you. But the main point that I want to make is that core formation during stellar evolution is not gravitational, okay? Maybe gravity can play a smaller role. Gravity can play a smaller role as the star collapses upon itself and all the elements combine into molecules. But for the most part, forming the core is mostly magnetic, and it's reliant on ionized material to sort the material out. Hopefully this can help people. If they have any questions or comments, please leave them below. But this is all tentative. Maybe I'm missing something. I'm not too sure. That's why I'm putting it on YouTube. But I'm also putting it on YouTube because I've seen not a single place in the entire internet, and trust me, I've been looking. I've been searching scientific articles all over the place, and I have yet to find anybody that says that the core of the Earth was electroplated during stellar evolution. That's obviously because, hang on, let me get my eraser here. Go ahead and write this out for you guys. The reason why they don't have electroplating as being important is because stars are fusion reactors. And this is the big idea that's getting in the way of all astronomy and astrophysics. This is the idea that needs to be discarded. But as long as they have that idea, they're going to be nowhere near what actually happens to a star. So hopefully this this is a cause for epiphany for most people. But all right, see you guys later.